Hello everyone, myself Paula Makwara, Assistant Professor of EC Department at LJ Institute of Engineering Technology. Welcome to section of Digital System Design. In the last session we have finished unit number 1. So in today's session we are going to start unit number 2, that is a combinational logic circuit design. First of all, in this session we are going to study what do we mean by combinational circuit design, what are different types of combinational circuits. Alright, over here the combinational logic circuit is a circuit in which we are able to combine a different gates. Alright, for example, encoder, decoder, multiplexer, demultiplexer, half adder, full adder, half subtractor, full subtractor, likewise. Okay? So it is basically consists of logic gates whose output depends only on the present input. That's it. Okay? Over here, this is the block diagram of combination logic circuit, which is having the n number of inputs and m number of outputs. Alright? You can see over here that my output will only dependent on the input. So if there is any change in the input, it is going to be reflected at the output side. Alright? So what are the different characteristics of combinational circuit? First, the output of combinational circuit at any instant of time depends only on the level present at the input terminal. Second, the combinational circuit will not use any memory. Why? Because my output is only dependent on the input. Okay? So I don't need any memory to store that output. Alright? Third, the previous state of input does not have any effect on the present state of the circuit. That means my output will depend only on the present state of the input. It won't depend on the previous state. Alright? Fourth, combinational circuit can have a number of inputs. That means n number of inputs and m number of outputs. Okay? So it does not contain any memory element. So these are the characteristics of combinational circuit. In general, it has n boolean inputs, n boolean outputs, and n switching function, each mapping the 2:n input combination to an output such that my current output depends only on the current input values. Alright? So first, we are going to focus on half adder. As I have discussed that a combinational circuits have different types like half adder, full adder, half subtractor, full subtractor, multiplexer, demultiplexer, decoder, and alright. So first we are going to focus on what we mean by half adder. So half adder is the combinational logic circuit with 2 inputs and 2 outputs. So what is the function of the half adder? It is designed to add a 2 signal bit. Let's say the binary numbers are A and B, and gives you a 2 output. The outputs are sum and carry. Okay, this is the schematic of half adder, 1 bit half adder. That means at a time it will add only a single bit, right? See, A and B is the input, S and C, sum and carry is the output. So what this truth table signifies? It signifies two inputs are there, so total combinations are 4, 0, 0, 0, 1, 1, 0, 1, 1. And based on the input, you will get the output, sum and carry. 0, 0, that means your sum is 0, carry is also 0. Addition of 1 with 0, sum is 1, carry is 0. 0 with 1, addition is, sum is 1, carry is 0. Then fourth is 1, 1. Sum is 0 and carry is 1. Alright. Now if we are going to form the Boolean function for this sum and carry, you are able to find that two ones are present. One is for the case 1, 0 and second is for the case 0. As 1 is there for A, the main term will be like A, B dash. For second case, A dash B. So your Boolean function for the sum is A dash B plus A B dash. So that is the logical function of XOR gate. So A dash B plus A B dash, that is the logic function of XOR gate. Alright, so output is sum. Now for the carry, it is like there is only a 1 is present. For which case? For the fourth case. For A and B both are 1. So your function will be like AB, right? That means A dot B. So in between A and B, what is that? Non-operation. That means AND gate is there. Okay, AND gate. This is your sum output. This is your carry output. Okay, so this is the realization of half adder. Alright. Now what is full adder? So full adder is developed to overcome the drawbacks of half adder. Now what are drawbacks of half adder? Half adder will add only a single bit. And the full adder provides the addition of 2 bits. Okay, it can add 2 1-bit number A, B and the carry C. So full adder is having a 3 input and 2 output. Alright, 3 inputs are A, B and carry E, C inputs, and 2 outputs are sum and carry output. This is a final carry, like this. This is schematic diagram. 3 inputs, 2 outputs. A, B, C, A, sum and the carry output. Okay. Now, as there are 3 inputs, its total combinations are like 8. How? 2 raised to 3, that is equals to 8. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, up to 1, 1, 1. So now we are going to do first the summation. So 0 plus 0 plus 0, that means you will get a 0. Similarly, A is going to be added with the B, and the answer is going to be added to say A. Alright, so you will get the sum output. Likewise, for all the combinations, it is 1, 1, 1. So addition of 1 plus 1, that means sum is 0, carry is 1. And that 1, 0 is going to be added with the say A. So you will get the sum output 1 and the carry output also 1. Alright, so how to realize this output, sum and the carry? You are able to identify that for the sum, it is 1, 2, 3 and total 4 ones are there. Okay, so for the combinations are like A dash, B dash, C, A dash, B, C dash, A, B dash, C dash and ABC. Okay, so for that you need to require 4 AND gates and resultant will be applied to the OR. So this is the output of sum. Now for carry, find out how many numbers are there. 1, 1, 1, 1, 4, 0, 1, 1, 1, 1. Take it the mean terms. You are able to identify 0 to 3 ones are 1, 2, 3, 4. 4 ones are there. Okay. So after realizing with the help of 3 variable DRAM, this is a simplified logic circuit of carry out. Now, if I need to convert the half full adder into the half adder, you require 2 half adder with a 1 OR gate. Alright, this is a truth table that we have already discussed. So over here, the XOR gate with the AND gate, 1 half adder, AND gate and another XOR gate, second half adder, and combination of these two will give you the final carry output. Alright. This is the way that how to represent the carry out and the sum. Right? Now, what do you mean by half subtractor? It is the same as the half adder, that means it has 2 inputs and 2 outputs, but the outputs are borrowed inputs. That means the half subtractor will perform subtraction operation. Alright? So it is a combinational circuit with 2 inputs and 2 outputs. 2 inputs are AB, outputs are difference and the mode. Like this. A minus B is difference and borrow. Okay? How to write the truth table? 2 inputs, 4 combinations. 0, 0, 0, 1, 1, 0, 1, 1. Right? 0 minus 0, 0. 0 minus 1, it will be not going to subtract it, you need to take a borrow. Okay? So answer will be 1. 0 minus 1, so 1 minus 0, 1. You need to take a answer is equals to 0 for borrow. For 1, 1, it will be 0, and borrow will be 0. Alright? So you will get the answer for the difference like A dash B plus AB dash. This is for XOR gate. And for the borrow, you will get A dash B. So A dash you will take NOT gate, or B you will take a borrow. Now what is full subtractor?